I think we've got enough people in the webinar at the moment, so let's get started. Welcome to those of you who have just joined. My name is Mike Beaver. I'm the CTO at Principal Networks. With me, I have Neil Camden, a senior security architect, and Ian Wharton, who is the head of pre-sales at Principal Networks. The webinar today is going to be looking at securing your supply chain, so mastering that third-party remote access risk. With that in mind, let's kick off. So, the last perimeter, all of those companies that in a globally connected world are accessing your environment. In manufacturing, it might be those companies that maintain and look after and update your machines, whether they're glass cutting machines or extrusion machines. They're all internet connected now, and the manufacturers like to look after them. If you're a sales-driven company, it might be your marketing agency having access into your customer databases in order to market to them and ostensibly ask them to buy your products. It could be EDI, it could be ERP integrations, it could be all manner of reasons that a third party might come into your world. Now, traditionally and typically, those occur with VPNs. Okay, so with a VPN, it comes from the originating company. You are the destination. They can access your environment and off they go. There's very limited control. There's very limited capability around that. Okay, the reason for that comes down to identity. So identity is your primary form of access control. If you haven't looked at your identity strategy, then I encourage and urge you to do so. But knowing who is accessing your environment is as important as the access itself. If I break cybersecurity down to its simplest statement, I am worried about who is accessing my stuff. Stuff could be data or application or machine or IoT or any other number of things in your world, and what they can do with it. So taking control back of that is a huge step in providing a high degree of cybersecurity within your organization. Privilege access management is okay. So controlling that identity through privilege access management is okay, but it doesn't account for the network connection. That fact that you have got a level of exposure out to the internet where people can scan and they can find those VPNs simply doesn't offer the levels of security necessary in today's world. VPNs, I'm terribly sorry to say, cannot be zero trust. Please don't assume that they can. Zero trust has three core tenets. The first of which, no matter which form of zero trust you subscribe to, is the reduction in attack surface. Okay. If it is reachable, it is breachable, is one of the strap lines you'll often see in the industry today. And VPNs, by their nature, are internet facing. They have to be to accept incoming connections. They are sitting there out in your world, increasing your attack surface. There was literally another VPN CVE release just this morning. So please go and check that if you are a VPN customer. VPNs, the N in VPN stands for network. What that means is that when I connect to a VPN, I am connecting to a segment of a network. That means I can move laterally around that segment and potentially across segments and VLANs to other segments and other bits of network. Okay. Second core tenet of zero trust is zero lateral movement. Now, I can't do that by connecting to a network or a segment within the network. Okay. And then finally, they are network dependent. That means that it might solve access over a traditional mechanism, but what it doesn't do is solve access over web portals that maybe aren't network dependent, maybe those things that you have necessarily out on the internet that third parties log into. So we are not controlling those. We are connecting to a network, not a specific application, not to a specific destination. Okay. Another core tenet of zero trust: do not connect to the network, connect directly to the application. Okay, least privilege, least access. So if you are still using VPNs in that respect, I urge you, again, strongly reconsider that technology tactic and strategy. please look at reducing that attack surface and that lateral movement capability as much as you possibly can. Finally, privileged remote access in its own right as a concept, and the things that you are going to see today, or certainly a number of these things. One, controlling time-bound access. Please don't keep your VPNs always on. It's just asking for trouble. So if your third parties are accessing at specific times, time-bound them. It's also a handy and slightly sneaky way of enforcing SLAs. Yes, absolutely, third party. I will open access for you during this SLA window. If you miss that window, that's on you. We can prove that you missed your SLA. Sandbox file transfer. Again, if I'm uploading, downloading firmware into my environment, I want to make sure that goes through my sandbox to make sure there's nothing malicious coming in from the outside. Credential vault and mapping. Again, if I can inject credentials so that third party never needs to know what the access controls are, then that's all the better for my cybersecurity posture. Session termination ties in with session monitoring. If I see something particularly risky, I can terminate the session immediately. I'm in control of that. Just-in-time provisioning, there's some work you can do to automate the provisioning process to a specific piece of technology. So that just-in-time provisioning means that I am always in control of access internally and externally to that resource. Clipboard controls, I can stop copying and pasting inwards and outwards within my environment as well. So again, that data loss prevention, that credential theft, all of those wonderful things. Session recording, as you would expect. I can see what you did. I can replay it. I can see what happened. I can see what you've clicked on, what you typed, so on and so on. I can also monitor that in real time with session monitoring. Session proctoring and session notifications, again, I can do. If I've got just-in-time automation and provisioning, I can still do session proctoring. I can still do session notifications of when things occur, when requests are made, and I can tie that into all of my necessary workflows. So with that in mind, that is some of the things that you are going to get to see today. I am going to hand over to Mr. Neil Camden, who is going to talk you through and demonstrate all of these things to you. So Neil, please take it away.
Thank you very much, Mike. Okay, just a couple of slides here to show you the infrastructure we're dealing with here. So talking through in pictorial form what Mike's just described there. Massively oversimplifying the world of security and networking here. But essentially, the legacy way that the internet connectivity worked is you'd have a firewall, might be on-prem, might be in the cloud. You'd have your apps sitting behind it, and your users would access those applications either via a web browser to an IP address and a port that's advertised out to the internet, or you'd have a VPN client and you'd connect into that firewall using the VPN client. That's the way this infrastructure has worked for 20 or 30 years, and it generally works with some of the limitations that Mike's mentioned. You're connecting users into a network. You don't have that just-in-time aspect of only connecting users to the applications they need when they need them. So this solution allows connectivity, but it leaves you quite wide open. And then your hackers and your nasties that are out there have visibility of those endpoints as well, because the nature of VPN, the nature of this type of connectivity means that you have to have public IP addressing, you have to have ports open on the internet. So like Mike said, if it's reachable, it's breachable. So let me just wipe off all my bits and pieces from there and show you the modern way of doing it, the zero trust solution. So the zero trust solution is a similar sort of setup, but what you have, instead of firewalls, we have app connectors in the Zscaler world. These app connectors publish out the applications that are available behind them, but they publish out that application to the Zscaler cloud. They're not visible on the internet. There is no traffic allowed in here. Anyone on the internet cannot see these IP addresses or these ports as being reachable. The only way you can reach these applications is once you've authenticated and authorized through the Zscaler cloud. Now, the traditional way that works is you have the Zscaler client. The Zscaler client connects you to the Zscaler cloud. You authenticate your identity, as Mike says, very, very critically important these days, but also the posture of your machine, what you're trying to connect to, what time of day it is, what country you're coming from, all those sort of posture extra information can the Zscaler Cloud can decide, based on all the information I have about this user, do I allow them onwards to access this application via the app connector? That's all great if you've got the Zscaler client. If you've got a third party or a partner or someone in your supply chain that doesn't have the Zscaler client and you can't enforce that client onto them, that's where the PRA solution comes in. And what that allows us to do is, using a browser, you connect into the PRA portal, which is a web portal hosted in the Zscaler Cloud. You go through that same authentication authorization process and the same posture rules potentially, and the same policies and rule sets as if you had a client on your machine. And based on those, that Zscaler security engine, again, you allow access onwards via the app connector to the applications you need to get access to. And those can be HTTPS web-based solutions, they can be SSH, they can be RDP, can be VNC. And with updates that are coming soon to this, it'll be any product, any port, any UDP, TCP port can be sitting behind that. So it allows you to provide user to application access based on just-in-time requests. So you're still allowing users without the client to access your services that are hidden behind a secure gateway, but you don't need a VPN client and you don't need to open your environment out to the internet in any way at all. In this solution, all these back-end systems are invisible on the internet. The only way they can be seen or reached is by users who are authenticated through the Zscaler Cloud. So I hope that makes sense. That's massively oversimplifying it, but we'll move on from there to a couple of demonstrations that show exactly what this infrastructure looks like when it's in use. So first one is about 5 minutes long, and this is just showing you how the Zscaler private access solution works, which is the sort of fundamental basis for what we're going to look at in a minute. In this session, I'm going to demonstrate Zscaler Private Access, or ZPA, and this is a service that allows you to protect your private resources that may be on-prem or in the cloud, and you can put a security layer in front of that such that users can only connect to it if they're authenticated through the Zscaler Cloud, normally by Zscaler Client. But we'll come on to some other ways that you can authenticate a little bit later. And this is just a little demonstration to show how this works with and without the client running. So in this scenario here, in Azure, we have a web server running. It is reachable on this public IP address, 4.234 address. And you'll see in our network security group, we're allowing access to this server on port 80 and 443 and port 22 from anywhere. So basically this server is available on the internet. So if we can check this, we connect to this public IP address, you'll see we're getting through to a web server hosted in Azure. There's an internal 10.10 address and an external public address. We're connecting via the public address, and that's allowing us in using port 80, port 443. If I start to have a PuTTY client here, you will see I can also connect via PuTTY to that same IP address. If I log in here, you see that we're connected to an SSH instance there directly across the internet, so no real security in place. Let me show you what happens when we make some adjustments here. So what I'm going to do is I'm going to amend this network security group to block traffic from the internet on port 80 and 443 and also on port 22. So now that IP address is not reachable from the internet. So if I duplicate this session, you'll see that the PuTTY session won't get through. Equally, if I refresh this web page, see it keeps spinning. So this server is now not available on the internet on port 80, 443 and port 22. So not reachable at all. Not reachable, not breachable. Attackers can't get to it. So how do you provide connectivity securely into those services? But if I start up the Zscaler client, which you'll see at the moment isn't running, down the bottom right here. Start running the Zscaler client, and you'll notice there might be a little flash as the client starts running in the background and then appears in the bottom right. I'm not being asked to log into this client in any way. What it's doing, it's taking my Windows login, passing that through to Zscaler, authenticating me against the Zscaler cloud, so putting me into the right groups within Zscaler based on my group domain department membership within our Entra ID. And I will now be hitting a set of rules within the Zscaler cloud. So now that Zscaler client is running down here, You can see I'm enrolled into the Zscaler Private Access service. What I can do now, if I try to get to this same web server via its internal address, you'll see I can reach it by its internal address. So that's a private address, not reachable on the internet. The only reason I can get to that is because I've authenticated through the Zscaler cloud. If I do the same thing with SSH, the new session, again connect to 10.10.4 internal IP address, and now log in. You can see there, connected in an address across the internet because I'm authenticated into the Zscaler cloud. This is just an error from my previous failed connection, but you can see I'm on there, working. So that's how the Zscaler client allows authenticated users to connect into the service. And you can see, again, just confirming back here, the only address that is allowed to connect into this server is 10.10.10.5, and that is a Zscaler app connector, which is a small virtual machine that sits up in our Azure service. So what's happening here is the web server is advertising its availability to the Zscaler app connector. The app connector is announcing to the Zscaler cloud, this service, this server is available on this internal IP address and this port via me. So I have a policy written within the Zscaler cloud that allows me as a user using the Zscaler client to connect through to that web server. So that's how it's secured. That's all great if your users have the Zscaler client, but what if you want to allow users for access, for example, for third parties or employees that have BYOD devices? What we can do there, if I stop running the Zscaler client, in your environment, your users probably wouldn't be able to stop that. And if I go back to this browser and put in a website, so what's happened there is that URL that I've typed in has actually forwarded me to the Zscaler cloud, and the Zscaler cloud said, you're not authenticated, you're trying to get to a resource that requires authentication, you need to authenticate. So you can see it's brought up Microsoft sign in, and that's because we hand off our Zscaler authentication to an existing Entra ID. So if I log into that using my Entra account, see that I get challenged with an MFA request. So this is my existing MFA set up in Entra that's brought this up. So this is not anything new that needs to be created in Zscaler. Zscaler is handing off authentication via SAML or OIDC to my Entra. Entra is saying this user needs to go through MFA to connect. So I'll go through that, and that's through the authentication app on my phone. And you'll see that has now authenticated me and allowed me through to that web server. So again, I'm not running the Zscaler client. If we look here, this web server is not reachable from the internet on port 80 or 443. So the only way I'm connecting to this through a browser is through authentication through the Zscaler cloud. So you can see in that way, it allows for a consistent, centralized security platform where all your connections to your web servers and your services sitting in your private infrastructure, whether it's via client or via browser, are being authenticated through the same engine, the same single sign-on, the same set of rules, so you get consistency regardless of how your users are accessing your private resources. Now, this is limited just to web traffic, this solution. We do have an extended solution to this called PRA, which extends this connectivity out to SSH, VNC, and RDP, and we'll move that onto that into the next session. In this session, I'm going to demonstrate Zscaler.
Thanks for that, Neil. I'm just going to quickly put that video into a bit of context. So that first video was, as Neil said, it was ZPA, so Zscaler for private access, to access corporate applications privately via client connector, or clientless via a user portal, a web portal. There are several other licenses involved within PRA. We're going to go on to the next videos which illustrate the PRA solution, which as Mike was saying, is for primarily third parties to access internal services. So that might be something like a jump box internally that you allow third parties access to manage internal resources, for example, that kind of thing. And a lot of businesses have different solutions for accessing them. They might have a client VPN that they push out to the third parties' PCs. They might have a site-to-site VPN, for example, that kind of thing. Or they might just restrict access to it based on source IP address. There are a number of different ways that businesses use to allow that kind of access. But the difficulty with all of them is that they all have challenges. They're all insecure, as Mike was saying. VPNs are not a secure access mechanism. They all lack control, policy, and monitoring. So what we're going to see now is the standard PRA feature within Zscaler. If we have any existing Zscaler customers in the audience, it might be that you actually have standard PRA. Zscaler bundle this license with some of the features. So it might be that you've implemented Zscaler for a particular use case, and as an additional feature, you've got standard PRA. You might have it. And then the subsequent video is looking at the advanced features for PRA. That is licensed separately. And you can also implement just PRA on its own. You don't have to have the rest of the Zscaler features. So you don't need to take the ZPA feature set as well as PRA if you want. If you're just looking for a PRA solution, then you can implement that yourself. As Mike said earlier, if you do have any questions, please put them in the Q&A. And with that, if we can go on with the next video, Neil, that'd be ideal.
Thank you, Ian. In this session, I'm going to give you a quick demonstration of the Zscaler Privileged Remote Access Portal. And this builds on the ZPA, Zscaler Private Access Service and infrastructure that we've talked about previously, which allows users who are authenticated to the Zscaler cloud to access private resources within your infrastructure, either in the cloud or on-prem. The demonstration I've shown previously shows access to web service and also using SSH with the client running. But what if you need to give access to third parties or users with BYOD devices who don't have the Zscaler client on their machine and you can't enforce them having it? Well, the PRA portal is exactly for that. It's a web portal that's hosted within the Zscaler infrastructure and allows users to access SSH, RDP, VNC connections via that browser, but securely and after authentication authorization through the Zscaler platform without the need for dedicated VPN client. To show you how this works, we've got a portal at pre-sales PRA portal at principalnetworks.com, which actually forwards to a Zscaler hosted website. And you'll notice as soon as I get there, I'm prompted to authenticate. So because I'm not logged in, I'm not running the client, the Zscaler platform doesn't know who I am, so it's asking me to authenticate before I have access to anything at all. And you'll notice it's a Microsoft authentication, so we've already set up our Zscaler to authenticate against our existing Entra ID. If I authenticate here, my username, my password, and you'll see I get an MFA request. So this is not something that's set up in Zscaler because we've handed off our authentication to Entra or any other IDP you may have in place, such as Okta, Ping, something like that. Any MFA and policies you put in place in your IDP are carried out by your IDP, and that IDP passes back a simple yes or no response to me. So I'm just going to have to jump on my app on my phone, approve my sign in with my Authenticator app. I've done, and you'll see based on me authenticating correctly and depending on what user groups, departments I'm in within Entra, it's passed that back through SCIM integration into the Zscaler cloud and then gives me access to this PRA portal. And you'll see I have a couple of consoles or tiles here available, and these are visible based on my user the user I am, the department I'm in, and the policies that apply to me. So been given here an IDP server I can connect to and an SSH server. If I log as a different user, I may see different tiles. So just as an example here, if I click on this SSH tile, it takes me through to an SSH connection to a web server in the background. So I know here that my username and password for this. And we'll see that has taken me onto an SSH terminal on a privately hosted web server sitting in our Azure environment, reachable by a 10.10.10.4 address. So this is not reachable on the internet. There are no ports required on my Azure firewall to make this available on port 22 on the internet. Attackers can't see it. It's not vulnerable to scanning or people poking around looking for vulnerabilities. The only way you can reach this SSH terminal is through authenticating through the Zscaler cloud first. But you can see I've reached that via a web browser without having to run the client. So you can see how this would be powerful to allow third parties access to your private resources. For example, could be an IT company that look after your switches. And on this this portal here, you might have 10 or so SSH terminals so that a third party could come in and SSH directly to a switch, for example, or a router, or a UC system, or a web server, or whatever it may be. So very, very secure, zero trust way of connecting users to applications. You're not connecting the user to the network, you're connecting a specific user to a specific application. And just because I can reach that SSH server doesn't mean I can actually get to any other servers on the network, whereas the legacy way of doing this would be through a VPN client, which would get the user onto the network, from which point they would normally have access to all the resources available on that network, because they're then considered a trusted connection through that VPN. Zero Trust does away with that idea of trusting someone just because they're connected, and it will re-authenticate and re-verify every connection every time it's made. So again, because I'm authenticated and I'm connected to the network here, doesn't mean I can get to anything other than the resources that I'm allowed to get to. Close that off. You can see here I've got an RDP tile. If I click on this RDP tile, I've got a username here. It's demo. My password is you'll see that's taking me through to 10.10.10.6. So a Windows server running RDP, and I'm RDPing onto that, again, without having the Zscaler client running, but I've been authenticated through the Zscaler cloud and via my Entra IDP. And the rule set that's put in the Zscaler cloud will look at who am I? Have I authenticated? What departments am I in? What time of day is it? What type of machine am I coming from? Do I have the right operating system on my machine, for example? And you can control who has access to your resources based on granular posture controls, not just authentication, who that person is. So you can see there, again, without the client and just through a web browser, I have access to an internal private RDP host, very, very simply. In this session, I'm going to give you a quick tip.
Thanks for that again, Neil. So quickly, that was PRS standard. More about connectivity to services. This next video is the advanced features. So it illustrates a lot of the features that Mike was talking about earlier on at the beginning. So it's more about control. So I think we'll dive straight into that as we're running on time.
Okay, in this session, I'm going to show you some of the PRA advanced features. So I'm going to go to pre-sales PRA portal.principalnetwork.com. And again, it prompts me to log in. So I'll log in using my Entra account. We'll see, using MFA again. To approve that on my application, my phone. So that's taken me into the PRA portal, and you'll notice that this time the two tiles are still visible, but they're grayed out, and they do have a little no entry sign, so I can't actually click on these and access them. In order to have access to these applications, I need to click on My Approvals and request access. So I'm going to request access here to both of these servers. Click Next. On access today for an hour. Next and save. And what's happened now, you'll see that says pending. So I have a request for access to these two servers has gone off to a predefined group. So my colleague Ian will have been emailed with the fact that somebody's requesting access to a server, and he will respond to that email and either approve my request or deny my request. So over to you, Ian.
Thanks, Neil. So yes, I've got that email. Just clicking on the portal connection there. I can approve or I can reject. I will approve it. Time window, custom time.
Okay, so now Ian has approved me. If I refresh this page, we'll see that those two are marked now as approved instead of pending. And if I go back to my consoles, you'll see that both of these tiles have now gone green. I can click on the SSH tile. It takes me straight into the SSH console on the Linux box. Now you'll notice I haven't had to put in any credentials here, and that's because one of the other POA advanced features is we're able to pre-configure credentials in the back end of the POA portal. So when I connect to the SSH server, it's actually taking credentials that are pre-configured and passing them onto the server and logging me in using those credentials. So it means this platform is able to give access to me, Neil Camden, as an authenticated entry user, and allowing me access to the SSH server without me needing to know the credentials. And just having a look on Ian's machine here, you see in the ZPA admin portal, he's gone into privileged remote access live sessions. And you can see my live session and can click on the icon on the right of this to join the session and monitor it. So you can join this and actually see what's going on in the session I'm connected to. And there we go, he's joined my session. And you'll notice what's just popped up there. Ian Morton at Principal Networks has joined the session. So this is another additional advanced feature, which Ian is kindly demonstrating there, where as an administrator, he's able to jump in and join this session and see what I'm doing. We can actually share the screen. He can type things in he needs to do. He can guide me on what I need to do if I was a third party, or for administration, compliance, auditing purposes, he can see what I'm doing. So it's a really nice feature to be able to share access to these privileged portals. You'll notice at the top here there's a little record button as well. What that is we've also pre-configured these tiles such that when a user connects to them, the session is recorded. So again, a great feature for auditing. Means if you allow a third party on, or anyone on, even an employee with a BYOD device, you've got evidence, auditable evidence of exactly what they did while they were connected. So let me close this one off, and I will just connect to the RDP server as well, just to demonstrate how that works. And you'll see again, logged straight into the RDP server. I haven't needed to put any credentials in. It's just taking me in with the credentials that are pre-programmed in the PRA portal. So as a user, I don't need to know the credentials here. One of the other features that's available in the advanced license is the ability to control, to some extent, what users can and can't do when they're on these privileged connections. So we have tied down the use of copy and paste, for example. So we do have a shared clipboard up here. If I click on this URL, for example, and copy it, it says here clipboard copy is denied due to capability policy. So I can't copy and paste anything off this web page. For example, I wanted to type in not allow text, for example. I can copy that, go back to this website. And on this page, try and paste, and let me paste what I've tried to paste across. So you can control access, allow people access to RDP or SSH servers, but prevent copying and pasting. Similarly, you can allow or prevent file transfer as well. We have file transfer disabled on this setup here. So you can see there's no additional buttons here, but you can enable file transfer if you want to do in a controlled manner. Right, just going to jump across to the admin portal, just show you what some of this looks like over here. In Analytics, Privileged Remote Access, under Live Sessions, you can see my connection here, RDP, and this is where you can monitor the live session. So that's where Ian clicked on this link from his admin portal early on to see what I was doing and share the live session. If I wanted to share this with another person, forward a request to an email and say, join this session. And I can also terminate this live session from here. Also in here, you will see you have recordings. So this recording that we're on at the moment here is not available because it's still ongoing. So if I just go back to here and I end this session, close this window, we'll go back to these recordings. I'll just refresh that. You'll see this is completed, and in a minute that will be available, and I'll be able to actually look at the video of the session and everything that was done in that session. So additional features on top of the basic PRA access. The access through the PRA portal is already pretty secure. It's authenticated through your IDP and single sign-on, and you can see with these additional security features we can tie down much more specifically what users are able to do once they're connected to those terminals, those consoles, those servers sitting behind the PRA portal. Okay, in this set, there we go. That is the end of the 3 demo sections there for you.
Thanks, Neil. Superb work as always. Thank you, ladies and gentlemen, for giving us your time today. We have run slightly over. If there are any questions, please remember that the question and answer panel is open. Please type those questions in and we'll answer any that come up in there. If it's about PRA particularly, if it's about third-party supply chain risk, if it's about Zscaler, more than happy to help. You've got 3 experts in the technology with you here now. We'll leave the chat open for a couple of minutes. If not, that's the end of the webinar. Thank you very much for coming again, and we look forward to speaking with you all very, very soon.